Our existence has something to do with the movement of the solar system through the galaxy. Researchers have found that there is a galactic rhythm of 200 million years that affects everything on our planet. Be sure to stay tuned to the end to join me on this crazy journey through the galaxy. And if you like it, I'd be delighted to receive a thumbs up and a comment, because that way we can get the YouTube algorithm to show this video to even more people. Welcome, friends. Sad fact, I won't have another birthday for a few million years. At least if you take a galactic year as a reference value, because that takes 225 million Earth years. But what is a galactic year anyway, and why do you have to measure on such a large scale? Our Earth is pretty sporty, you guys could learn a thing or two from it. It revolves around itself, it rotates around the sun, and as part of the solar system, it moves around the center of the galaxy, the Milky Way. This movement of our solar system is completely unknown to many people, but we are racing through the Milky Way right now and at a speed of 900,000 kilometers per hour. When you woke up this morning, you were in a completely different place in space, millions of kilometers away, so you never have to go on vacation again. Your whole life is a wild journey through the cosmos on a spaceship called Earth. Well put. I'll have to remember that. And it takes 225 million years to orbit our solar system around the galactic center, which is called a galactic year. Somehow it seems likely that this galactic year could have a significant impact on Earth, doesn't it? We're talking about huge periods of time here. At the beginning of this galactic year, dinosaurs still existed on Earth. There are many researchers who believe that the Earth's climate and geological and tectonic processes are also influenced by the galactic year, by our movement through the Milky Way, so you can already remember that as a good excuse.
Hi boss, I can't come to work today. My migraine is so bad again because of the galactic year.
And now they have found solid evidence that we even owe our existence to this galactic movement, as incredible as it sounds. Attention, now comes some poetry. To see a world in a grain of sand and a heaven in a wildflower, hold infinity in the palm of your hand and eternity in an hour. This is from a poem by William Blake, and it describes very nicely what geologists do. They look at a grain of sand or a stone and draw conclusions about the structure of the entire Earth from its composition. They see the world in a grain of sand, and that is exactly what researchers from Curtin University in Australia have now taken to the extreme, concluding from the structure of earthly rock to galactic processes. They have seen not only the world, but an entire galaxy in a grain of sand. Professor Chris Kirkland, who is leading the research, says, "We observe the composition of mineral grains that are smaller than the width of a human hair. Then we extrapolate the chemical processes to relate them to the Earth's place in the galactic environment." What exactly did the researchers do? They examined rocks from the Earth's crust and created a kind of geological timeline from the information that could be read from the rocks. For example, uranium is bound in crustal rocks, and its radioactive decay process creates a perfect chronicle that geologists can then interpret. In other words, they have determined a timeline of Earth crust production. When did the Earth's crust form, and when did the greatest transformation processes occur? And they found that there was an approximate 200 million year rhythm for the formation of the crust on the early Earth. Billions of years ago, when our Earth was very young, the Earth's crust underwent important developmental steps every 200 million years. 200 million years, that fits pretty well with the galactic year of 225 million years, doesn't it? And it fits even better with a partial movement of the galactic year. To find out, let's travel from the Earth's crust far out to the spiral arms of our galaxy. When the solar system and the supermassive black hole in the center of the galaxy move, they don't always remain in exactly the same place within the Milky Way. The movement of the solar system differs slightly from the movement of the spiral arms. The spiral arms circle at a speed of 210 kilometers per second, while the solar system moves at 240 kilometers per second. This difference in speed causes our solar system to surf in and out of the arms of the galaxy. Over the course of this long period of time, the solar system is sometimes in the middle of a spiral arm and sometimes a little further out. And between the entry and exit of our solar system into a spiral arm of the Milky Way, there are, you guessed it, 200 million years. This leads to only one conclusion.
Namely, that the government urgently needs to introduce a spiral arm tax.
So it all fits together perfectly. The only question that remains is to what extent this spiral arm surfing of our solar system could have determined the formation of the Earth's crust. And here I'll throw another term at you, the Oort Cloud. What's that again? It's a far-off area that represents the last frontier of the solar system. Here, the sun's gravity is just strong enough to keep objects like comets and dust particles in its grip. The Oort cloud has not yet been proven to exist, but that's only because our technical means are still too poor to see it. The laws of physics dictate that it must exist. At some point, the boundary must be reached at which the sun's gravity slowly loses the upper hand and the gravity of other stars within the galaxy becomes stronger. And it is precisely there that a shell-like envelope forms around the solar system. It is assumed that the Oort cloud is gigantic in size. It could extend over 1.5 light years. In other words, even at the speed of light, it would take you 1.5 years to reach the end of the Oort cloud. So it will take a long time before the Voyager probes reach the Oort cloud. For example, it is hard to imagine what might be hidden in these unknown regions of the solar system, but I can already hear you saying,
Oort Cloud spiral arms, what does that have to do with the Earth's crust?
when the solar system surfs into a spiral arm, the interaction between the stars and the interstellar matter of the spiral arm and the Oort cloud causes material to be released from the cloud and hurled in the direction of the inner solar system. Some of this material, i.e. comets and asteroids, has obviously hit the Earth in the past. Objects that have such a long journey to reach the Earth hit our planet at an immense speed. The Australian research team believes that the regular tracks they found in the crustal rock were produced by precisely these high-energy impacts from the Oort cloud, which were triggered by the movement of our Earth over the course of the Galactic Year. Insane, isn't it? I find the thought incredible that our everyday lives are ultimately shaped by these, for us, incomprehensibly lengthy galactic processes. Because if the Earth's crust had never formed the way it did, we wouldn't exist at all. Or at least not in this form. So it's high time to say, thank you, Oort cloud, thank you, spiral arms. Professor Kirkland puts it very nicely. It is impressive to look up at the sky and see the stars, and then to look down at your feet and feel the rocks. All of this is connected by a truly magnificent rhythm. And some of you have probably come to the same conclusion as I did. Could it not be that not only the Earth's crust was formed by these processes, but that perhaps life itself came to Earth in this way? A comet from far, far away, perhaps even from a completely different area of the galactic spiral arm, could have been hurled towards the Earth by this rhythm. This comet may have contained organic materials, or at least pre-organic things, such as amino acids. The thing hit the Earth, and thanks to this fortunate chain of events, I'm standing here now. The galactic rhythm is therefore a perfect complement to the panspermia theory, the idea that life on Earth somehow came from the cosmos. Now, I'm curious to hear your opinion on all the incredible insights I've presented to you in this video. What do you think? Does the galactic year really have such an influence on us? And if so, which processes on Earth could still be explained by it? With all these large scales and distances, I always ask myself, how could you travel the cosmos to experience everything firsthand? And of course, the key word here is the speed of light. And maybe it's even faster, and the answer is yes. The speed of light is not necessarily the fastest. To learn everything about this fascinating fact and how to travel faster than the speed of light, be sure to watch the video below. And if you want to support the channel, click on the shop button and get the shirts from my videos, real meteorites, and astronaut food in my space shop. Otherwise, I'd say see you in the next video. Take care, friends.